Alright guys, now we are on chapter 8, and in chapter 8 we're going to deal with roots and radicals. So the first thing that we have to do in 8.1 is we're going to evaluate roots, and we need to know that a square root is the opposite to some value that's squared. Okay? Then we're going to look at the Pythagorean theorem. Which is this is the a squared plus b squared equals c squared. And then the last thing that we're going to look at is the distance formula. Okay, and I will show you what that is in just a few moments. 8.2, we're going to be multiplying, dividing, and simplifying roots. So we're going to use the product rule. We're going to use perfect squares. And then we're going to use perfect cubes. Okay, which you've seen those in chapter 6, but we're going to bring them back because what we're trying to do is we're trying to simplify the roots. Then we're going to add or subtract radicals. So really all you can do here is you can combine like terms after simplifying. Then in 8.4 we're going to be rationalizing the denominator, because you can never have a square root in the denominator. Then we're going to work more simplifying operations with radicals. This is where we're going to look at the distributive property. We're going to look at FOILing. We're going to look at conjunctions. And then we're going to simplify with the triangle method. In 8.6 we're going to be solving equations with radicals. How you do this is the most important section actually. You're going to isolate the radical or the square root. Then you're going to square both sides. And then you're going to solve. Sometimes it will be linear, sometimes it will be quadratic. So meaning you might get one answer or you might get two. And then in 8.7 we're going to use rational numbers as exponents. So we're going to go back to our exponent rules, like the power rule. And with the power rule we have am to the nth equals amn. So what that means, if I have x to the second raised to the third power, all I do is I multiply my exponents. So it would be x to the 6th. And we'll work on that together. So that's kind of an outline of what chapter 8 is all about. So please use this as a good study guide for your chapter 8's test. Alright, so today what we're going to do is we're going to be evaluating roots. So first thing we got to do is we got to define what is a radical. A radical is an algebraic expression containing a square root and a number and or a variable. Okay, so this actual square root, or what we usually call a square root, is also known as a radical sign. Okay, we typically call it a square root, and I'll probably refer to it more as a square root than a radical sign, but technically it's called a radical sign. Whatever is found underneath the radical or square root is called the radicand. Okay, and this could be a number, it could be a variable, or it could be both. And then this entire thing is known as a radical. So the whole thing's known as a radical. So an example of this, I got my radical sign, so I got the square root of 9. So the square root of 9 is going to be plus or minus 3. And we have to make sure to cover both. So whenever we have an even root, we got to make sure, if we're taking the square root of it, that we put our plus or minus. If we got an odd root, like this 3, so we got the cube root of 27, what we would do is we would take 27, we go up arrow to the 1/3, and when we plug that into our calculator, we're going to get a positive 3. So if it's an even root, make sure you carry the plus or minus. If it's an odd root, it carries whatever the sign is. So since it was a positive 27, we're going to keep that positive 27. And then the last one is the square root of 25x squared. So because it's an even root, we're going to put plus or minus. Square root of 25 is 5. And then the square root of x squared is just x. Okay, so that will be this answer. Okay, so solving by factoring versus solving by the square root property. So in this would be section 6.5. We have x squared minus 49 equals 0. So if we solve that by factoring, and we have two terms, x squared minus 49 equals 0, two terms, it could either be a GCF or it could be a difference of perfect squares. This one is a difference of perfect squares, so what we do is we take the square root of the first term, so the square root of x squared, which is x. We take the square root of the second term, which is square root of 49, is just going to be 7. We set up our parentheses, plus minus, x plus 7, x minus 7 equals 0. Then we split them up and we go x plus 7 equals 0, x minus 7 equals 0, and then we solve, so subtract 7 on both sides. So x equals negative 7, add 7 on both sides, x equals positive 7. Okay, so that's one way that we could solve by factoring. Now we can solve by the square root property. And the reason you can use the square root property is because you have no b. Alright, so we got x squared minus 49 equals 0. So the first thing I gotta do, add 49 on both sides. So I got x squared equals positive 49. Now in order to get x squared to x, all we have to do is take the square root on both sides. But remember, when we put the square root in, we have to go plus or minus. So the square root of 49 is plus or minus 7. So technically, we get the exact same answers. This just took a little less work. Okay, and that's solving by the square root property. So, square roots and squares are opposites that undo each other. Just like the opposite of addition is subtraction, and the opposite of multiplication is division. Okay, so square roots and squares are opposites of one another. So if I take the square root of x squared, that's just going to leave me with x, because essentially this is what it looks like. You would go x squared raised to the 1/2. Okay, and remember that I multiply those two, so that would be 2 over 1, so this would just leave me with x, because 2 times 1 is 2, 1 times 2 is 2, 2 over 2 leaves me with x. Okay, so right here, if I do the square root of 49, I would be left with 7, and squares and square roots cancel each other out, so I would have plus or minus 7. So if you want to take it with this technique to go plus or minus, and you see that squares and square roots are opposites of each other, you can totally do that as well. Now I'm going to change this one just up just a little bit, and I'm going to make it the square root of y to the 4th. So if I have y to the 4th, what I would initially do is I would go y to the 4th raised to the 1/2. Okay, and I put that over 1. And if I multiply straight across, I've got y to the 4 over 2, which would reduce down to y squared. So anytime that you have an even root, so we got the 2 there, so this is the square root and you have an exponent, all you have to do is divide it by 2. Okay, so let me show you another one. So if I take the square root of y to the 8th, all I would need to do is take the 8 and divide it by 2, so it would be y to the 4th. So if I had the square root of x to the 12th, 12 divided by 2 is 6, so this would be x to the 6. Alright, now let's look at this one. If I got the square root of 25, what times what gives me 25? So 5 times 5, so 5 squared. Square roots and squares are opposites of each other, so I'm left with plus or minus 5. Okay? Let's do a little bit more practice with this. So if I get the square root of 0, square root of 0 is just 0. 0 is neither positive nor negative because it is part of the origin. It's where your starting point is if you were to graph a point. Alright, now I've got the square root of 81 over 121. What times what will get me to 81? 9. What times what gets me to 121? That would be 11. So this would be plus or minus 9 over 11 because squares and square roots are opposites that undo each other. Now, this next one, I've got minus the square root of 36. So what they're actually asking for is they're asking for the negative answer. So this time I'm not going to put plus or minus, I'm just going to put the minus, and the square root of 36 is 6, so that's going to be my final answer of negative 6. Because they don't care about the positive answer, they just want the negative because it's outside of the radical or the square root. Now, we're going to work backwards. So we know that square roots are opposite to some value squared. So if I square a square root, what ends up happening is they just end up canceling out. So my answer would be 17. But let me prove this to you. What you can do is you can go the square root of 17 times the square root of 17. And you can multiply that out. But we know a square times that exact same square will give me just 17. Okay? So now let's look at b. I've got in parentheses negative 30, or the square root of 31 parentheses squared. Okay? We know first that a negative times a negative is going to leave me with a positive. And we know that a square is an opposite of a square root, so my final answer is going to be 31. But I could see this as negative square root of 31 times negative square root of 31. So negative times a negative is a positive. And then square root times the exact same square root is just going to remove that square root for us and leave us with 31. Okay, this is where it actually becomes important. So if I've got the square root of 2x squared plus 3, I know that squares and square roots are opposite of each other, so what ends up happening is I'm just left with whatever's underneath the square root. So I got 2x squared plus 3. And that's going to be really important, especially when we get into chapter 9. Alright, so radicals come in 3 types. We can have perfect squares, we can have irrational, or we can have not real. Perfect squares are also known as rational numbers, okay? And this means when you take the square root and the answer is a whole number, okay? So if I take the square root of 64, I'm going to get plus or minus 8. And since that's a whole number, it will be known as a perfect square, or it could be known as a rational number. Either way completely works for me. So then we're going to look at irrational. And when you take an irrational number, when you take the square root, and the answer is a real number that is continuous. So what this means, if it's continuous, it goes on forever and ever and ever. So in your calculator, I want you to do the square root of 17. And when you take the square root of 17, you get 4.123105626. Okay? And whenever you see an irrational number, I want you to round 3 places past the decimal. Okay? So if I'm going 1, 2, 3 places past the decimal, it would be 4.12. Alright? And if I'm dealing with the 3, I look 1 past. If it is 4 or below, you stay the same. If it is 5 or above, you go up or give it a shove. So since it is a 4 or below, you just stay with the exact same. So my rounding rule would be 4.123. Now, if it's a not real or an imaginary number, the way that you can tell this is when you take the square root of a negative number, but it's inside of your radical. So technically, the square root of 49 is 7, but because I have this negative number, what that means is I have to pull out an imaginary. So my answer would be 7i. Okay? And the plus or minus does not matter here. So it can either be a perfect square, irrational, or a not real number. So now what we're going to deal with is the Pythagorean theorem. We use to find the length of the sides of a right triangle. The way that you know you have a right triangle is that you have a box. Okay? Whenever you have a box, that means you have a right angle. And whatever's across the right angle is always known as your hypotenuse. Okay? This will be your longest side. This is also known as your C whenever you write your formula. Now the two that are adjacent to the right angle are just known as the legs. And it doesn't matter if this is A and this is B, or if this is B and that's A. So whenever you have to use the Pythagorean theorem, you're going to have a right triangle. The way that you know it's a right triangle is that you have a box, and whatever side is across from your right angle is always known as your hypotenuse, which is your longest side. Alright, so now what we're going to do is we're going to find the distance of the unknown side. So we got A equals 6, B equals 8, and C equals blank. So we're trying to find out what our C is. And we're going to use the Pythagorean theorem. So in order to do this, we go A squared plus B squared equals C squared. I do expect you to write your formula every single time. I will not give it to you for your test. So you go 6 squared plus 8 squared equals C squared. Once you write your formula, it becomes a simple plug and chug. 6 squared is 36 plus 8 squared, which is 64, equals C squared. And 36 plus 64 is going to be 100 equals C squared. Then I take the square root on both sides and I get 10 equals C. Now, even though I took the square root, distance and length can never, ever, ever be negative. Okay? So my answer for C is going to be 10. Alright? Problem B, I have A equals 5, C equals 9, and B equals blank. First thing I want to do is write my formula for the Pythagorean theorem. So I go A squared plus B squared equals C squared. My A is 5, so 5 squared plus, I don't know my B, B squared equals 9 squared. 5 squared is 25 plus B squared equals 81. Now I just got to solve this, so I'm going to subtract 25 on both sides. So I got B squared equals 56. Then I take the square root on both sides. And when I plug this into my calculator, I'm going to get an irrational number because it's going to be continuous. So I go 7.4833147774, which will be 7.48. Got around 3 places past, so that 3 makes it stay the same. So it's 7.483. Okay, this is an irrational number. Alright, and this right here is known as a rational or a perfect square. I would take either answer. Okay, now what I want you to do is I want you to practice it. So pause the tape and go through these two problems for me. Alright, so we got A equals 24, B equals 10, and C equals blank. First thing I want to do is write my formula, so I go A squared plus B squared equals C squared. Then I plug in what I know, so 24 squared plus 10 squared equals C squared. 24 squared is 576 plus 100 equals C squared. I add those two together, I get 676 equals C squared. Take the square root on both sides. Square root of 676 is going to be 26 equals C. Alright, now for my last one, I've got A equals 5, C equals 13, and B equals blank. First thing I want to do is I'm going to write my formula. So A squared plus B squared equals C squared. I want to plug in what I know, so I got 5 squared plus b squared equals 13 squared. 5 squared is going to be 25 plus b squared equals 169. I subtract 25 on both sides. So I got b squared equals 144. I take the square root on both sides, so b equals positive 12. And both of these numbers are rational. Or you could call them a perfect square. Hopefully you did well on them. I will not give you this formula, so you need to make sure and know it. The last formula that we're going to deal with is the distance formula. And the distance between 2 points. So you got an x1, y1, and you got an x2, y2. And the formula is d equals the square root of x2 minus x1 parentheses squared equals y2 minus y1 parentheses squared. Alright, so I think the easiest way to kind of identify this is if you have an x and you got a y. Okay, so you got your point A, and then maybe you got your point B right here. So what we're trying to do is we're trying to find the distance between these 2 points. Okay, so how you do this is you subtract the distance of the x's, and then you square that value because it can't be negative. Then you take the distance of the y's and subtract those two, and then square that value because it can't be negative. Then you add those two together, and then you take the square root. So first step, you're going to label your 2 points as x1, y1 and x2, y2 because every point goes x and then it goes a y. Then you're going to write down your formula and plug and chug. So let's make it real. First thing I want you to do, cross out the formula. If you talk through it, it makes it a lot easier. Alright, so find the distance between the 2 points. We have negative 6, negative 6, 3, and then we've got negative 2, negative 4. The first point that I see, x1, y1. Second point that I see will be x2, y2. Now in order to find the distance, I know that I have to take the square root of my x2 minus my x1 squared, so I have to subtract my x's and I have to square that value because it can't be negative. Plus, then I gotta take my y, so y2 minus y1, subtract those two, and then I have to square that value. Once I write my formula, then I can plug and chug. So I'm going to go negative 2 minus negative 6, parentheses squared, plus negative 4 minus 3, parentheses squared. So when I clean this up, it goes change, change. So negative 2 plus 6 is going to be a positive 4 squared, plus negative 4 minus 3 is going to be negative 7, parentheses squared. So 4 squared is 16. Negative 7 squared is 49. Because a negative times a negative is a positive. I add those two together, and I get the square root of 65. When I put the square root of 65, I don't get a whole number, so this is going to be an irrational number. And we know for an irrational number, we're around 3 places past the decimal. So when I do the square root of 65 in my calculator, I get 8.06225, which will be 8.062. And it's irrational. Okay? We got one more. First thing I want you to do is I want you to take out your formula. Alright, so we're going to find the distance between the 2 points. First point I'm going to label as x1, y1. So negative 4 is my x1, and then 3 is my y1. Then negative 7 is x2, y2, because it's the second point that I see. So to find the distance, I take the square root, and I subtract the x2 minus x1, parentheses squared, plus y2 minus y1, parentheses squared. So I take the difference of my x's, square that value, plus the difference of my y's, and I square that value. Then all I have to do is plug and chug. So I take the square root of negative 7 minus negative 4, parentheses squared, plus 1 minus 3, parentheses squared, change, change, so negative 7 plus 4 is going to be a negative 3, parentheses squared, plus 1 minus 3 is negative 2, parentheses squared. So when I go to the next step, negative times a negative is a positive, so negative 3 squared is going to be a positive 9. Negative 2 squared is going to be a positive 4. So D equals the square root of 13, which again is an irrational number. So we have to round it 3 places past the decimal, so I got 3.6055. When I round it 3 places past the decimal, if it's a 4 below, you keep the same. If it's a 5 or above, you give it a shove, so you move it up 1. So this would be 3.606. And it's an irrational number. So on your homework, I expect to see every formula. So if you have a Pythagorean theorem, make sure that you write that formula. And if you have a distance, make sure that you write that formula as well. If you don't, it'll be half off. Alright guys, go ahead and start your 8.1 homework, and if you have any questions, please make sure that you bring them to class. Thank you.